So as Matthew said, I'm a co-organizer of Toronto JavaScript. I'm going to be talking to you about VanillaJS, and that's my Twitter up there. But it's just full of silly stuff. So if you just want to concentrate with silly stuff, you can follow my Twitter. If you want awesome JavaScript events in Toronto, follow TorontoJS. So as Matthew mentioned, we really do this for you guys. And for me, I've actually been doing JavaScript for about 14 years now. It's the first language I ever learned 14 years ago, trying to build video games. And I quickly discovered you can actually build video games with JavaScript 14 years ago. So I switched to C and C++. But JavaScript was very close to my heart, and I really enjoyed JavaScript. And when the opportunity came to take over the group, I immediately jumped on it because there really has to be a good JavaScript presence here in Toronto. And I'm very happy to talk to you about VanillaJS. So moving forward, and yes, I am presenting in Vim. Vim's awesome. So moving forward, I'll basically be basing my talk on this awesome resource. It's called JavaScript Garden. Highly recommend you to bookmark this right now. I'm sort of going to be using this as a textbook for this talk. I'm going to be going into a few of my experiences with JavaScript, but this is a great resource. They go over all the ins and outs of JavaScript, all the quirks, everything you need to know about the language, and it's actually created by this guy called Bonsai Dan. I couldn't find his Twitter, but it's now maintained by Tim Ruffles. So, please do check that out. I sort of got a few tidbits from JavaScript Garden, but take a look at it in your own time. It's really quite in-depth and quite awesome. So, before I forget, just throw questions at me. I sort of structured this talk in a way that, just put your hand up, ask me questions as I go. Happy to talk about them, and happy to answer your questions as I go. Perfect. So first up, in JavaScript, everything is an object. So I'm sure you've heard that a lot. And in JavaScript, once again, everything is an object. So we're able to call methods on things. So in this case, we have a false.toString. False is an object. We're able to call methods on it. An array is an object. We're able to call methods on that. A function is an object. We're able to assign properties to it and get properties from it. And sound's being edited, worked on. Numbers are also objects. So in this case, 2 is an object, and we're able to call toString on 2. In fact, in JavaScript, if we were to do 2.toString, it would give you a syntax error. So you have to wrap a few things in parens in order to actually call methods on them. 2 is an example of that. Only exception to the rule is null and undefined. Null and undefined are not objects in JavaScript, so you have to treat them a bit differently. You're not able to assign methods to them in this way, as you are in languages like let's say Ruby. Those are the only 2 things that aren't an object in JavaScript. So in JavaScript, objects are also data types. So in this case, we've created a new object, and we've assigned that new object to the variable of foo. It basically works like a hash map. You have sort of keys and values in a way, and that's how JavaScript objects essentially work. So in this case, we have bar as a new object, property of test assigned to the value of 12. So it's basically just like a hash map. All right, so property access. We have this object with property of name, a value of kitten. We're able to access it in this way. So foo.name gives us a value of kitten. We're able to access the same property through square brackets. So by passing in the string of name to square brackets, we're able to access the same property. Dynamic property access, we're able to use different variables within these square brackets. So in this case, we have a variable get, which is a value of name. It's the same thing. It's really just the same as line 110, where we get kitten. We're not able to do certain things such as use numbers. So foo.1234 is a syntax error, but foo square bracket string of 1234 works perfectly fine. So there are a few limitations to this, but one really cool thing is really just dynamic property access. I use that all the time in JavaScript, so just keep that in mind. Deleting properties. So once again, we have an object, bar, foo, baz are the properties, 1, 2, 3 assigned to them appropriately. We're going to assign obj.bar is undefined, obj.foo is null, and we're going to delete baz. So down here we have a bit of code. What does that end up printing? So that ends up printing bar as undefined and foo is null. That's because we just completely got rid of baz as a property. However, bar and foo are still properties. They just have the values of undefined and the value of null. So that's why bar and foo are print as undefined and null. Now, if you were at my FITC talk at the end of last year at Advanced JS, you know that you should never actually do this. You should always just assign it to null or undefined for JavaScript performance reasons. I won't get into all the details because that was a 45-minute talk in and of itself, but I'm happy to go through the slides with you later and go in a bit more detail with you later. What's best to do for JavaScript performance is actually assign the property as null or undefined and then do a nil check. That's actually faster in JavaScript than deleting a property. And once again, I'm happy to go over that after the talk. Prototypes. All right, so JavaScript has this very different object system than most other object-oriented languages, such as Java and Ruby and so on and so forth, in that JavaScript uses prototypes, uses chains of prototypes in order to create objects and inherit from objects. So in this case, foo is going to be our constructor. It's just an empty function for now. We're going to assign foo's prototype to a new object, a property called sayHello on that. And sayHello is a function where we're just going to console.log hello. So down here, we're going to use the new keyword. So the new keyword basically means run this constructor, do whatever's inside this constructor, assign this prototype to that instance, and that's what's going to be f. So we're able to say f.sayHello, and that gives us hello. So that's how prototypes work in a nutshell. But the thing about prototypes is that if you edit that prototype in any way, every instance of that prototype is also mutated. It's also changed. So that's in stark contrast to like Ruby and Java, where Java you just won't be able to do that in any way. But in Ruby, for example, if you edit a class definition, it doesn't change the instances. In JavaScript, it does. So if we go down here and redefine sayHello to accept an argument of name and change the console.log statement, we're now able to say that same instance defined above, sayHello accepts a name, and now we're able to say hello Taz. So whenever you change a prototype in JavaScript, you're changing every instance of that prototype as well, and that comes in handy further in my talk, or not, depends on how you look at it. Prototype chaining also works. So this is how you do sort of inheritance in JavaScript. We have this new function bar. Bar's prototype is the instance of f. It's a bit odd, but anyway, you can do that. B is a new bar. So once again, we're setting up the prototype and everything for that. B.sayHello. We never define sayHello on bar's prototype explicitly, but it's since it's the instance of f, we just have sayHello. And if we change sayHello on foo to say bye, B.sayHello now says bye as well. It completely ignores the argument. This doesn't accept an argument. It just says bye. All right, everyone with me so far? Cool. HasOwnProperty. So HasOwnProperty basically means if that object has that property explicitly defined on itself. So in this case, for every single object I have in JavaScript, I'm gonna change its prototype. So the main object's prototype, everything's an object in JavaScript. So therefore, changing this and assigning its value, its property bar to 1. Creating this new object foo doesn't have a property bar defined on it, but yet down here, foo.bar is 1, right? Because object.property, the prototype.bar is 1. In the same way, bar in foo is true because foo technically has a property bar, right? And if you want to really mess with websites, you can just change the object to prototype. It really messes up websites. Something else that's also fun is actually array.prototype 4 is equal to lol. That also really messes up websites if you want to have a bit of fun. But anyway. So now if we were to do foo.hasOwnProperty bar, it's false because once again, bar was never explicitly defined on foo, right? Bar was defined on object's prototype. It wasn't defined explicitly on foo. Only thing defined explicitly on foo is goo. And therefore foo.hasOwnProperty of goo is true. That rhymes, that's weird. So in that way, you can see what's defined on that object itself, what's defined in this prototype chain, et cetera, et cetera. So for in loop, we're going to do the same thing. Object of prototype bar is equal to 1, var foo moo of 2. Those are rhymes. And in the same sort of way, a for in loop will iterate over all the properties on an object. So I, in this case, are all the properties of foo. So console.log I will print both bar and moo because, bar is defined on foo as well as moo. So we can then use our HasOwnProperty to then take a look to see if that property is defined on foo and then only loop over the stuff explicitly defined on foo. So it can be useful in that way. Now So how does this work in JavaScript? So this was actually inherited from the Java language, and this works very differently than how it works in Java and other languages in that if we were to do this just by itself, this refers to the window object. This refers to the global object. In a browser, it's a window. If you use strict mode, this will actually be undefined in this case, but it generally refers to the window. Within a function, this still refers to the global object. It still refers to window. So if we were to return this, it still refers to window. Bar. So we have an object bar, property of foo. Foo is a function. This actually refers to bar. So the way that this works in that way is a bit weird. If we were to create a object, this refers to the newly created object. So once again, if we look at this as a constructor and we're creating a new instance off of that, this is that new instance, right? So in the same way within the prototype, this is the same instance as this up here. So we're able to, sort of create classes and create class definitions in that way by, using this and passing around this. So when we do new foo, this and this are the same thing. All right. You can also manually assign this. So this also, by manually assigning this, I need to stop saying this so much. By manually assigning this, you're able to do dynamic things. So in this case, function foo accepts A, B, and C. Bar is a new object. Here we're going to explicitly assign bar to the value of this and say 1, 2, and 3 are the parameters A, B, and C respectively. And these two statements are essentially identical in that foo.call with bar. Bar is now assigned to this, and then 1, 2, and 3 are A, B, and C. And if you're doing dynamic stuff with JavaScript, that's very handy. So closures and emulating private variables. So this is where everything starts to come together. I've sort of been building up to these next few parts, and this is where everything sort of comes together. So we have this function counter, which accepts an argument called start. We have this variable count, which we're now assigning to start, and we're returning this object where it has a property increment, which is a function. It's just simply increments count plus, by 1, and get was also a function that simply returns count. So down here we have foo, which is a new counter, foo.increment. We passed in the value of 4 to counter. Foo.increment will add 1 to that. So when we do foo.get, we get 5 back. All right. But this won't work, for example. So if we were to try to reach into foo and change the value of count, that won't work. Because foo is only available to functions that have it in scope. So in this case, this function has count in its scope, and this function has count in its scope. The function down here, this hack, does not work because count is not in its scope. And in a similar vein, this does not work as well because we never actually assigned count to this, right? Count is not available to that function in any way. You can't actually, manipulate count in any way. That won't work. So when we get count at the end of it, it's still 5, right? So we're able to emulate private variables by using closures and scoping in this way. All right, so a pretty common mistake is using a closure inside a loop. So in this case, we have a loop from 1 to 10, and we use a set timeout in JavaScript, and we essentially log I after a second. And what this does is it will actually print like 10 times because this loop executes, right? It's going to assign I to 10 once this is all done. And then a second later, I will be 10. So this console.log will execute 10 times, and it will say 10 times, right? Because I ends up being 10. So it's a pretty common mistake in JavaScript. One way to get around that is to use an anonymous wrapper function. So that's a big fancy word for essentially wrapping it in a function. So in this case, we have this anonymous function here, and we then give it the value of I, which is then passed into the function of E. That then gets called with console.log, and what this does is the intended is what's intended is in that it prints 0 through 9. Okay, and that's because within the scope of this function, E is always defined as the current value of I as intended. It's not what I is at the end of the loop. It's the intended value of I. Well, there's also a few other ways of doing this. That's just one way of doing it, but there's also a few other ways. All right, so putting this all to good use. So here we have a user model, and we have this. So once again, this is the same this as defined in our prototype. We have a name and we have an age. This.name is a name, this.age is age. We're going to create a prototype, and we're going to say greet this name. So once again, the name defined up here says hello. Increment age. Age is incremented appropriately. So once we create two user objects, Bob and Jane, Bob's 30 and Jane's 40, we're going to greet them. So Bob says hello and Jane says hello, right? Everything's fine and dandy because we created the name up here and we're using it down here. Pretty straightforward. However, we can do malicious stuff. So instead of greeting, we can just say a bunch of asterisks. So that's not very nice at all. And someone with malicious intent can simply modify the user's prototype. Once again, that changes every instance of user to this new function. And what that does is Bob greet. That's not very nice, Bob. Like a bunch of asterisks is not very nice at all. Jane.greet, same thing. It's not very nice. You have crying kittens. So a bunch of asterisks results in crying kittens. And once again, that's because you're able to manipulate the user's prototype, change greet to whatever you want, and that changes every instance of that user, of that user. So you're able to do malicious things with your code. You're also able to do this. So Bob.age is 45, Jane.age is -10. So once again, not the intended usage. You only increment ages. You don't just randomly set them, but by using prototypes, you're able to do this. And it's not very good. It could lead to malicious code. So a possible solution to this is to use factories. If you guys have done any AngularJS, there's a lot of factories in Angular, and they're essentially a solution to this problem. So in this case, we have a function foo. We have this object obj that we're building up, and this object will eventually be returned by our function, and that will be the object that we're moving forward with instead of a prototype. Object.value equals blub. We're able to use private variables a lot easier. You can't really use a private variable very easily with this implementation up here. It's extremely difficult to do so. It may not even be possible in certain ways. But if you were to use a factory, a private variable becomes a lot more useful. You're able to assign properties to the object. So obj.some method, in this case, this is actually obj. So obj.value is the value of this function. You're able to do that. And once again, return the private method because private in this case is available through that same scope. At the end of it, return obj. So we can use that down here using the same. With the same example above, we're able to rewrite the user class. So in this case, function user accepts a name and age. Obj is an empty object. Object.greet, same functionality as above. Increment age, same functionality as above. And in this case, we're not actually using this because name and age are actually private. It's private to this function, right? So name is here and age is up there again. We're not actually using this in any way. It's all private functionality. Get age simply returns the age because we have no other way of accessing it. Return obj. So note we're not using the new keyword. We're not setting up prototypes. We're not using the constructor function. The user function defined is technically our new constructor function. We're going to create Bob and Jane once again. And Bob.greet, Bob says hello, Jane says hello. We're able to increment Bob's age, and we get the new age. All is fine and dandy. Bob.age, we can't do that anymore. It's private, right? Age is a private variable. We're not able to do Bob.age. It's undefined. So let's try to do our malicious code again. So we're still able to do malicious code in JavaScript because it's JavaScript, you're able to change whatever you want. So bob.greet is equal to function of oh no, console.logs oh no. So bob.greet will give us oh no. But Jane.greet still says hello. Jane still says hello, so Jane's still polite. So if we try to mess with this further by saying user.prototype.greet is no, 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 Jane.greet still says hello. We're not able to change that in any way. And finally, user.greet Consuela says no. Jane.greet is still, Jane says hello. So we're not able to actually mess with that factory created object in any way. It's just really encapsulated just to that one instance. It's not encapsulated. It's not across every instance of that class. It's just that one little instance. So that's nice, but it has its drawbacks. So its drawbacks are that it uses more memory. If you use a single prototype, that uses less memory because you're then reusing that prototype throughout each instance. In order to inherit a factory from a factory, you need to copy all of the properties of the factory onto the new one. That takes time, that takes more memory. It's generally less efficient than using prototype. Dropping the prototype chain just because of a left out new keyword is contrary to the spirit of the language. So, JavaScript's a prototypal language. Not using prototypes isn't contrary to spirit to it. Essentially what that's saying. And in terms of JavaScript engines, prototypes perform better than factories in almost every single way. JavaScript engines are made to use prototypes, and not using a prototype, it's not good for performance. And once again, I'm happy to go through why, the exact details as to why this is the case after the talk. So basically what I'm trying to say is do what's best for your application. If you're building some high-performance video game or something like that, use prototypes, it's going to be faster for you. If you're building code that people are constantly messing with, maybe use factories, whatever's appropriate there. But it's important to be consistent. So like if you're going to use a new keyword, use the new keyword everywhere. If you're not going to use, if you're going to use factories, just be consistent with what you're doing. Okay, so moving on, type equality. So this is an area that JavaScript's really weird, and this is an example from JavaScript Garden where it just sort of shows its weirdness. 0 is equal to empty string, for example. That's true. 0 is equal to a string of 0. That's also true. False is equal to a string of false. That's false. That makes no sense. False is equal to a string of 0 is true. And so on and so forth. Null is equal to undefined. A lot of white space characters is equal to 0, which is also true. Type equality in JavaScript is a bit weird in that way. So generally, it's said to use the triple equals, which in all these cases returns false. It's a bit more predictable, and a bit. You sort of know what's expected when you use the triple equals. And what I've used is this technique of doing a not. So you're able to do not whatever, and that will tell you if it's truthy or falsy. In this case, not true is true, not false is false. Not empty string is false, and that's actually handy later on down the road. It's actually not very well known that not empty string is false in JavaScript, but not white space is true. So this is a truthy value. This is a falsy value, right? Object is true, not null is false, not undefined is false, not true is true, not false is true, not yes is true. So actually, we're looking at a piece of code that had not if yes as a string, and then do all this code, and it was a bit odd when you can just do true. But anyway, in practice, what I've done is just say if whatever, and then it'll only get inside this code if whatever isn't an empty string, if it isn't null, if it isn't undefined, or if it isn't any falsy values. Otherwise, deal with it. But once again, this if whatever is an empty string, that's actually quite useful in a lot of ways when doing just VanillaJS, in that you can sort of rely on that when you're expecting text input or whatever, and someone doesn't input anything in, you can just do if whatever, and it won't be an empty string. All right, type of and JavaScript classes. This is another, this is taken from JavaScript Garden, and it's just a little chart of how type of and JavaScript classes sort of match up. And as I said before, everything's an object in JavaScript. As you can see, everything is an object in JavaScript, and it's not very useful in a lot of ways. But the class makes a lot more sense. So in this case, we have a string of foo, we have a new string of foo. The class is both string. That makes a lot of sense. The type of makes no sense. How come this is a string and how come this is an object? It makes no sense at all. Same with numbers. Same with booleans, dates, errors. These are all objects. That makes no sense at all, but the class makes a lot more sense. Regular expressions. So this is often tripped up on in that in V8 and Nitro, which is used in Safari. Regular expressions, the type of used to be function. So in older Safaris and in older V8s, you used to get function back when you do a regular expression. So if you're looking for a callback, for example, and you're saying if type of equals function, if you pass in a regular expression instead of the callback, it's going to, evaluate to true, which is going to then try to execute a regular expression, which is not going to work and throw an error. So that's something to watch out for, is that, it's actually a function in V8 and Nitro as opposed to others. And, these two are really the only ones that make sense. Objects are objects. So you're probably wondering, how do I get this class in JavaScript? JavaScript doesn't technically have classes. How do I actually get that? And the answer to that is down here. So when you call toString on JavaScript objects, you actually get the class as part of the toString call. So by doing some finagling and object.prototype toString call, by assigning two strings this to object, slicing out the class, and if object isn't undefined or null, then you're able to do sort of tests like this. So if is test a string, it is new string test a string, it is. So anyway, you're able to get it in that way. And that's really what I had to talk about today in terms of VanillaJS. That's really the core language, something that I use myself. As I said, take a look at JavaScript Garden, take a look at that site. It's just about everything in there. I didn't go into a lot of it. Obviously, there's quite a bit to know about JavaScript, but I'm happy to take any questions. Yep.
Place where you explained inheritance, you assigned the new classes, like inheritance class, instance, reason equals that. What do you mean, why is it the instance?
Let me just go back to that bit of code. Oh, sorry. Sorry, do you mind saying the question one more time so I can repeat it over the mic?
When you explained prototypical inheritance, the class that inherited the parent class, you said constructed equal to instance of the parent class.
Okay. Okay, so what the question was in this example up here with prototype chaining, where I have this new bar object. Why am I assigning bar's prototype to f? Why does it have to be the instance? And the answer to that is it doesn't actually have to be the instance. It can really be any sort of other object. And in this case, f's prototype has say hello defined on it. So in this case, I'm just demonstrating prototype chaining, where bar's prototype will then look up through f's prototype and then find say hello in f's prototype defined on foo. And in that way, you can actually do inheritance and prototype chaining in that way. Okay, anyone else? Yep.
Is there a straightforward way to use prototypal inheritance inside something like a library, and yet not leak any references to that dicey?
Yeah, so you can actually use closures and private methods in that way. So you're able to scope that entire prototype, scope that entire object within your closure, within your function. And if you use private variables, as I detailed somewhere in here, then there we go. If you're able to use it sort of in this way, where you sort of have a function, private class, you're able to keep it within the class in that way, so you won't leak it out if you were to do something like that. Yes.
You said you've been using JavaScript for like 14 years.
Yep.
Has that been purely front end, or have you been doing back end?
Well, back in those days, it was purely front end. I mean, like I sort of looked it up on the web and said JavaScript can be used in the server. And I said, no, it can't. At the time, it was purely front end. And at the time, I mean, all you were really doing in JavaScript was like asking for a prompt of someone's name, or trying to like document write things. I mean, it was a whole other world in terms of JavaScript at that time. But it was purely front end.
Hearing, like being used in the back end as well, and I'm kind of wondering, like people that are using it in the back end, I mean, are there interfaces to file systems, databases, and stuff like that, or I mean, how are people using it?
Oh, for sure. Well, if you take a look at Node.js, Node.js is a great project, and they have a great standard library as to how you can actually access file system access, like ports on the computer. You really have full access to the underlying hardware using Node.js. Very recently, Java 8 came out with Nashorn. Nashorn gives you access to the Java ecosystem, so you can actually use Java's built-in image manipulation, Java's built-in file system access. You can actually use threads within JavaScript for the first time, which is sort of very weird, but kind of crazy at the same time. So there are a lot of server-side JavaScript stuff out there now, and yeah, it's really quite a different world of JavaScript these days than it was 14 years ago. Yes.
I'm related to this, but I think it has something to do with VanillaJS. When you have an object in main global area, and you pass it, let's say an array, and you pass it into a function, and you make changes to that array, you add variables, or you change the contents of the values in it. Does the global get changed, or it's only in the local version of the function?
So if I'm understanding you correctly, you have a global array,
Right.
and you pass that within a function to a function, and then you manipulate the global array. You manipulate the global array within the function.
Exactly.
Yes, then that would still manipulate the array everywhere else where it can be accessed.
It's always a reference.
It's a reference passed. Yes, that's correct. Yeah. You're able to duplicate things in certain ways. It changes from library to library, framework to framework, but you're able to replicate things as well if you so desire, duplicate things. But by default, it's by reference.
For your own work, I mean, do you put any or much effort into creating a namespace to get around the issue of it all being global?
I do. So for me, sorry, the question was, do I put any work into keeping things out of the global space and sort of namespacing things? And I do. I actually use this private variable technique quite frequently. That's when certain frameworks came out, such as like Ember.js, for example, everything is global. You can manipulate anything, wherever you want, everywhere. And that's one thing I personally like about other frameworks, in that you're able to emulate private variables in certain ways. And through private variables and namespacing, I'm able to get around, global property access and making everything available in JavaScript. Cool. Anyone else? Yes. Sorry? Oh. Yeah. Sure. I'll give the TLDR version, which is essentially the way that JavaScript engines work is that it expects certain properties to be around. So if you have one object and you have another object, and then in this object over here you delete a property, the way that JavaScript engine sees it is that these are two completely different objects. Therefore, it has to re-optimize everything to deal with like objects of this type and objects of this type, as opposed to objects of the same type, if that makes any sense. I can go into a lot more detail, but that's really the gist of it, in that you're really, the way that JavaScript engines will look at it, they will look at it as completely different objects. So that's why if you were to assign a property, if you instead of deleting the property, if you were to just assign it undefined, it would still look at them both as the same object. Therefore, it wouldn't have to re-optimize. It wouldn't have to, clear out all of the stuff that is done to make your JavaScript fast. It can just execute them all in the same vein, and your nil check will, catch the fact that property is now undefined. Okay, and if that is all, we're gonna take a break first of all, and then I'll pass it off to Matthew, who will then show you how to use VanillaJS with HTML to then manipulate the DOM and so on and so forth. All right, thanks so much.